Welcome to our webinar on inventory optimization. In this webinar, I will be walking you through the key concepts, methodologies, and benefits of optimizing inventory levels for businesses. Let's start by looking at some of the major inventory management pain points that companies often face. The first one is poor on-shelf availability, and this is a critical issue, where products customers want to purchase are frequently out of stock, leading to lost sales and dissatisfied customers. Warehouses crammed to the rafters with the wrong inventory is another common challenge. This ties up excessive working capital in inventory that doesn't match actual demand. Excessive inter-branch or inter-warehouse transfers are needed to reposition misplaced inventory to where it's required, adding significant logistics and handling costs. Too much working capital is invested in inventory overall due to challenges in properly balancing inventory against demand and optimizing deployment. Too much slow-moving or obsolete inventory builds up as a result of forecast errors and inefficient inventory policies, representing cash being unnecessarily tied up. Last but not least, customer service failures and back orders occur frequently due to a lack of the right inventory in the right locations to meet demand in a timely manner. So, what precisely is inventory optimization? The inventory optimization is the analytical practice of determining the ideal inventory levels, positioning and policies for each product or SKU to meet forecasted customer demand. The goal is to hit target service levels like fill rates or order cycle times, while minimizing the overall working capital tied up in inventory and other operating costs. Some of the key questions inventory optimization helps organizations answer are we prepared with sufficient inventory buffering for unexpected black swan events? How do we determine what the optimal inventory levels are for each SKU across our network? At what specific points or nodes in our supply chain network should we hold inventory? What are the right individual inventory levels that balance target service levels and costs at each stocking location? The benefits of deploying an advanced inventory optimization solution are substantial. For example, it allows improving forecast accuracy by leveraging machine learning and other advanced forecasting techniques to better predict future demand at a granular SKU level. Companies can maintain or improve their service levels to customers while reducing the overall investment tied up in inventory through optimized stocking policies. So, in brief, the better service with less inventory. Moreover, optimized safety stock levels are calculated at each stocking location, providing the right buffer to account for demand and supply variability. The other important point is the time phase replenishment plans, and these plans are created outlining when and how much inventory to flow through the network to meet demand at least cost. And finally, excess and obsolete inventory levels are minimized by aligning forecasted demand to stocked quantities. At a detail level, the inventory optimization process determines the optimal inventory and replenishment parameter settings and policies for each individual SKU by location. This feature enables increasing overall inventory turnover and reducing expenses for distribution, procurement, and capital costs. It minimizes the need to expedite production or transportation to cover stockouts with associated premium costs. Altogether, the optimized inventory policies improve metrics like order fulfill rates, back order levels, and other service measures corresponding to increased revenue. Basically, inventory optimization leverages advanced optimization techniques. Optimization problems involve maximizing or minimizing some objective, like minimizing costs or maximizing service levels, subject to real-world business constraints and trade-offs. Optimization is used across many areas like investment allocation, workforce scheduling, facility location, vehicle routing, and more. The general goal is to manage the efficiency and utilization of limited resources in an optimal manner. Inventory optimization combines machine learning capabilities for predictive analytics like demand forecasting with mathematical optimization for prescriptive analytics to make optimal inventory planning decisions. The predictive piece uses techniques like regression, neural nets, decision trees, etc., to forecast the future demand based on patterns in historical data. The prescriptive or optimization piece takes these demand forecasts along with business rules, goals, and constraints and determines the optimal inventory policy to meet service targets at least cost. It's this powerful combination of predictive and prescriptive analytics that delivers optimized inventory policies, precisely tailored to each company's unique network, products, and objectives. Some of the key inputs to our inventory optimization engine include detailed demand forecast profiles by SKU, location, and time period generated by the predictive forecasting models. The other input is data on replenishment lead times from suppliers and lead time variability to properly model supply risk. Another input is any capacities or other operational constraints that need to be factored in, like limited distribution center receiving slots. The company's specific inventory policies like target customer service are another important inputs for this solution. And finally, product data like shelf life that impacts how inventory must be managed. With these outputs, the inventory optimization software employs advanced algorithms to calculate outputs like optimal safety stock levels by SKU at each stocking location to buffer against forecast errors or supply delays. Also, the other input that it generates is the optimal reorder point. And this means the inventory position at which replenishment is triggered for each SKU. And finally, the optimal reorder or replenishment quantity that should be brought in. All these parameters are optimized to hit the target service level at the lowest overall inventory investment. And our solution has many capabilities and features, but here we want to just go over some of the most important capabilities and features of this comprehensive inventory optimization solution. For example, inventory segmentation to automatically group SKUs by attributes like value, velocity, obsolescence risk, and other factors, and apply tailored policies. Also, this solution has true multi-echelon optimization across all stocking locations in the supply chain network simultaneously. In addition, it has integrated warehouse operations optimization to ensure labor, space, and equipment capacity at facilities can support their replenishment plan. It supports the ability to align inventory planning with the organization's overarching corporate strategy, financial goals, and supply chain and operations processes. Last but not least is the self-service data visualization and reporting to analyze, optimize inventory policies, and simulate scenarios. Also, it provides flexible deployment models for on-premise or cloud to meet your IT requirements. The visual dashboards allows you to analyze and visualize the optimized inventory policy outputs. For example, you can see recommended safety stock levels by SKU compared to current and current actuals, or examine reorder points, order quantities, and other metrics. Scenario analysis allows testing different demand forecasts, service target levels, or other inputs to understand the projected inventory investments. Here we can see some successful use case stories and success stories about implementing an inventory optimization solution. For example, a food distributor could just in a short time ran 1 to 2 percentage points above their 92% goal between 93 to 94% daily. This company continues to sustain impressive service levels above 95% every day, with monthly highs reaching up to an exceptional 96%. The other important success story is for a retailer company, and despite adding new customers, their inventory levels remain the same. And actually they leverage the solution, and it helps them not only support their growth but achieve a 20% increase in sales while maintaining an overall 98% fill rate, even during their critical rollout period for their new customers. Also, another food company could reduce their overall inventory investment by 16% across the network, while simultaneously they increased customer service levels by 6%. In brief, inventory optimization leverages cutting-edge technologies like machine learning and optimization to determine the ideal inventory levels and deployment policies for each product in a company's network. And an optimized inventory solution embeds best practices, processes to drive continuous improvements over time. I hope this comprehensive overview has helped illustrate how inventory optimization enables businesses to achieve inventory perfection.